I'm going to talk you through a few examples of ordering. Now, when I say ordering in mathematics, we're talking about putting numbers in size order. When the numbers are whole numbers, as these are, that's a very easy task because the correct order is going to be the order in which numbers would come if you counted. Now, this is assuming you're putting them in order from small to large. Sometimes you have to put numbers in order from large to small. So the first thing that you should do is check which way, meaning large to small or small to large. Now, for the purpose of my examples, I'm going to put them all in order from small to large, just to keep the explanation clear. Well, from this set of numbers, first of all, you need to look at all of them. And this is the least, 11. So if I were to put these in order from small to large, 11 would be first. So I'll put a 1 for that. Then going upwards, the next one would be 57. Then 86. And the others are into 3 figures. So they're into the hundreds, and 152, followed by 391, which is the biggest of them. So you should never have trouble putting whole numbers in size order. The only time that you might is when the numbers have more digits. So when they're into the thousands or the hundreds of thousands or the millions, in which case, of course, all you need to do is put commas in the right places. So a comma after the thousands column, a comma after the millions column, and that will make it easy to put those in size order. It's more challenging when you have decimals. So here we have an example of 5 decimal numbers which we have to order from small to large. Since these are mixed numbers, which means that they're a combination of a whole number and a fraction, then we would begin by comparing the whole number part. We have 84, 83, 84, 84, 84. Clearly, 83 point something will be less than 84 point something, regardless of what the decimal places are. So the smallest is definitely 83.99, and I'll mark that as 1. So if you like, that one has now been eliminated from our list. We can now just compare the other 4 numbers, which are all 84 point something. Since they all have the same whole number part, 84, we must compare the next column, which is the tenths column. Here we have 6 tenths. We've already eliminated this number. 0 tenths, 6 tenths, 2 tenths. Well, 0 tenths is the next smallest number. So this is 2. So that one is now also eliminated from our list. Now comparing the tenths again, we have 6, 6, and 2. So this is the next least after 0 tenths. So this is the third smallest number. Now 84.64 and 84.65 have the same number of tenths. Because they both have the same number of tenths, we need to go to the hundredths column and compare what they contain. This has 4 hundredths and this has 5 hundredths. So this is less, and out of those 5 numbers, 84.65 is the largest. So to sum that up again, when you have mixed numbers, which means a whole number and a fraction in one, then compare the whole numbers. 84, 83, 84, 84, 84, 83 is the smallest. Since all the others were 84s, we have to compare the decimal parts. Here we have an example of a set of numbers. They are mixed numbers, but they have different numbers of decimal places. So we have 2 decimal places, 3, 2, 4, and 1. When you're putting numbers in size order, you must compare the highest value columns first. So we have 6, 6, 5, 6, 6. Well, 5 is the least. So in other words, this number is less than 6 and all the others are more than 6 because they're 6 point something. So this is obviously the smallest number. So we can eliminate that one from our list straight away. All the remaining numbers are 6 point something. So in order to put them in size order, we need to compare the next column, which of course is the 10th column, or if you like, the first decimal place. 1/10, no tenths, so this is the smallest. 1/10, 2/10. This is the smallest because it has the least number of tenths. So this is the second smallest from the whole list. Notice it doesn't matter how many decimal places they have. That's not the criterion. We have to work our way from the most valuable towards the least valuable, eliminating or ordering as we go. All the others contain more than 0 in their tenths, so they're all bigger than this. Now, comparing tenths again, we've got 1/10, 1/10, and 2/10. Well, the one which has 2/10 is bigger than the two numbers which have only 1/10, because we've already established that they all have the same number of units. They're all 6 something. But this is 6.1 something, this is 6.1 something, and this is 6.2. So this is clearly the biggest number there. Then to decide which is the next out of 6.17 and 6.1054, again, we compare like with like. So they're both 6.1 something. So we compare the next column, which is the hundredths, or the second decimal place. So we have 7 hundredths compared to no hundredths. So this is bigger, this is smaller. So this is third in our list, and this is fourth in our list. That is the correct order. Some children are confused and they tend to think that the more decimal places there are, the bigger the number, but that means that you haven't thought enough about place value. One of the causes of you to misunderstand place value, and therefore to get questions like this wrong, is misreading numbers. I would always discourage you from reading this as 5.91, because when you read it as 91, you think of it as 91. It is not 91. It's 9/10 and 1/100th. So you should read it as 5.91. Those same people would read this as 6.1054. And because 1054 is a large number, they think, oh, therefore this one must be bigger than this one and this one and this one. It's a mistake, and it's a mistake because you're reading this wrong. It's not 1054 because this is not the thousands column, this is not the tens column, and this is not the units column. This is 10,000ths, this is thousandths, this is hundredths, and this is tenths. You read this number as 6.1054 to do yourself a favor and not get confused about the value of the digits. Another skill that you need to have is to be able to put numbers in size order, or decimals in size order, which contain negatives. So it may be a combination of positives and negatives, like in example 4. You may be able to do it just by looking at them because you have a good feel for numbers, but the idea of a number line is useful to avoid any kind of confusion. The way that you would use the idea of a numbers line is to actually draw a number line or only picture it in your mind and mark the positions of the numbers on the number line. So let's do that. 3, because it doesn't have a minus sign in front, is taken as a positive 3, which is above 0. So this would be 3. Then minus 2.8 would be on the negative side. There's minus 2, there's minus 3. Minus 2.8 will be closer to minus 3, and it will be 0.8 of the way down. So if I mark that as 4/5 of the way down, because 0.8 is 4/5 as a vulgar fraction, so that's minus 2.8. Minus 1. .7 positive, so there's 4. 5 would be at the top of my blue line, so 4.7 will be 7/10 of the way to there. That is 4.7. And finally, minus 4.9, which obviously is very close to minus 5. 9/10 of the way from -4 down to -5, so I will say that is there. Having done that, I have just put the numbers in size order. So the one that's highest on the number line is the largest or the biggest or the greatest number, so 4.7, then 3, then -1, -2.8, -4.9. Or if you want them from small to large, then start at the bottom, because the lowest number on the number line is also the least. So it's from smallest to biggest, which is what we were doing here, is -4.9, then -2.8, then -1, then 3, and of course 4.7 is the biggest.